Hello folks, Dave Mayo here from HackYourGut.com, and today we're going to talk about the importance of energy to the gut. Now, many of you may not be aware of this, but the gut is an energy hog. It uses a ton of energy, and while you probably think that a lot of that is from digestion and absorption, you would actually be wrong. So today we're going to kind of discuss this, where the energy is going, how we produce the energy, and things we can do to optimize the amount of energy in our gut. So the gut has a high energy demand. Anywhere between 10 to 20% of our oxygen consumption goes to the gut, which means it's pretty close to the amount of energy that the brain uses. And this is important because there's something called the expensive tissue hypothesis, and basically it states that both the brain and the gut use a ton of energy, and if you can kind of decrease the energy demand of one, you increase the energy yield to the other. So for example, one of the ideas of how we've kind of evolved our bigger brains, our more effective brains, is that by cooking our food, we've kind of taken some of the energy demand off of our gut for breaking down and absorbing, or breaking down our food, and we can absorb it more rapidly. We're getting more energy yield from that food. That can help us build a bigger brain. So if you have these two expensive tissues, if you can kind of get one to use a little less, that can kind of direct some to the other. Now within the gut, much of the demand, the energy demand in the gut, is actually driven by things other than digestion and absorption. For one, there's a high cell turnover. Our gut replaces itself effectively every 3 days. And with high turnover, that basically means you have to recreate new cells from scratch each time. That requires a lot of energy. In addition to this, there is mucin production within the gut. Mucin is part of our mucus layer. And what mucin does, what our mucus layer does, is it keeps our microbes from getting too close to the cells that make our intestinal lining. Within our small intestine, we just have a loose layer, and it is constantly flowing away from the epithelial cells, and it's pushing bacteria out so they can go out the back door. In the colon, we have a dense inner layer and a more kind of a more sparse outer layer. Same deal though, it's constant production, and to constantly produce this requires energy. Tight junction formation. Tight junctions hold the cells within our gut together, and we want to make sure that they're tight because then we don't want things to leak through. Constantly utilizing or creating tight junctions to prevent the slippage of bacteria and food from our gut into our bloodstream. That requires a lot of energy, and we haven't even begun discussing digestion and absorption. So basically, just to keep the gut in a healthy state and not even performing the major functions that it does requires a lot of energy. So where is this energy coming from? Well, it comes from the same place energy comes from within all of our cells in our body. So when we look at energy metabolism within the cell, we get energy in the form of ATP. So we take ATP, which is adenosine triphosphate, and then we break off one of the phosphates, which leaves us with ADP, adenosine diphosphate, and that releases energy that we can use. In order to get that energy back, we need to add a phosphate back onto ADP to make ATP. And to do that, we have something called the phosphagen system, which is basically this compound creatine. Creatine binds to phosphate and holds onto that phosphate, and when ADP requires a phosphate, creatine releases it, and then ADP becomes ATP. Very rapid. It just can't make a ton of energy because it's kind of a one-for-one thing. With our within the other, what you're probably more familiar with energy systems, energy metabolism in the body is glucose, lipids, and amino acids. Within the enterocyte, which is the small intestine, glutamine seems to be the preferred fuel source for those cells, whereas in colonocytes, which are in our large intestine, those tend to use butyrate. Up to 70% of their energy man is fueled by butyrate. So, of course, in the small intestine, food, glucose, lipids, amino acids are available from our diet. However, in the colon, that's not really the case unless you overeat, which you don't want to do. In our colon, we get a lot of our energy sources in our colon from microbial fermentation. When the bacteria in our colon ferment fiber, we get short-chain fatty acids, primarily butyrate, but also acetate and propionate. Hypoxanthine, which is a purine, which is primarily used for nucleotides. You can also use that for energy. And then host glycans, which were the mucin, mucus layer that we make. The mucins, we can actually, microbes within our colon can ferment those, the glycans within there, and that actually releases propionate, another short chain fatty acid. So we have these sources of energy, and they're different between the small intestine and the colon, so it's important that we make sure both get fed. Now, butyrate is really interesting because in addition to fueling colonocytes, it does a lot of beneficial things too. When our colonocytes utilize butyrate, what they end up doing is sucking all the oxygen out of the kind of general area. So we get a much more hypoxic or lower oxygen environment, which is good because a large number of the microbes, the beneficial microbes in our colon, are anaerobic. We don't want a lot of aerobic bacteria there. So the other thing it does is butyrate also promotes tight junction formation and mucin synthesis. And part of this is probably related to the high energy yield they get from it. But when you do feed the colon, if you get a lot of butyrate in there, you're going to get a lot of you're going to get a better tight junction formation and greater mucin synthesis, a better mucus layer. So you can get butyrate both from amino acids and from fiber. The problem is when you get it from amino acids, there's several toxic byproducts that are going to kind of come about, things like ammonia, hydrogen sulfide, for example. These things can really have a deleterious impact on our gut. So you can get them from amino acids, but currently, based on the data, it seems the preferential way is through the fermentation of dietary fiber. Now, what's kind of interesting in this talk is there does seem to be an energy deficit in ulcerative colitis, which is a form of inflammatory bowel disease. There's an energy deficit for a couple of reasons. One of the interesting ways, for one, it does seem that potentially creatine transporters might be messed up in people with IBD. They also tend to make less butyrate, and they don't metabolize the butyrate that they make very well. And they do also happen to have high levels of something called hydrogen sulfide, which actually impairs butyrate metabolism, so it can become problematic. But in addition to the potential that an energy deficit causes inflammatory bowel disease, is the idea that the factors associated with inflammatory bowel disease actually promote this energy deficit. So things like inflammation, you're going to attract a lot of immune cells to the area, and they're going to utilize a lot of the energy. Accumulated damage, you have to repair the damage or replace the cells. That requires a lot of energy. And then there are broken microbial energy circuits. So our microbes in our gut cross feed off of one another, and if you miss a couple here or there, these energy circuits might break, and then so losing a keystone species that's responsible for attracting other species can lead to problems. So all this is said and done, how do we get adequate energy into our digestive tract? First and foremost, the easy one, creatine monohydrate is a supplement that you can take that may prevent energy gaps within energy metabolism because it provides it very quickly, quick way to recharge energy. You can slowly ramp up your fiber intake. What that will do is it will provide more butyrate towards the colon. You just want to make sure you do it slowly because you don't want to cause excessive bloating from the gas production that comes with the fiber. You want to limit foods that you're sensitive to, that are personal foods. Some people don't tolerate dairy well, and some people have an issue with gluten. But you also want to limit things like alcohol and smoking that are also inflammatory throughout the body in general. Decrease sulfur intake, specifically sulfur amino acids. You don't want to excessively consume these. These are things high in methionine and cysteine, which generally are going to be, meat, animal sources of protein. The reasoning behind this, the salt, we can only absorb so many of these sulfur amino acids. The rest are making it to the colon, and then sulfate reducing bacteria, if you have a lot of them, are going to make hydrogen sulfide. Your gas is going to smell like sulfur, and you're going to impair butyrate oxidation because the enzyme that detoxifies hydrogen sulfide is the same enzyme. They use the same enzymes, butyrate oxidation and detoxification of hydrogen sulfide. So we have that. And then finally, aligning your circadian rhythms is beneficial. What you're doing by aligning your circadian rhythms, getting light during the day, being physically active, eating during the day, is you're coupling energy. You're basically coupling the amount of the need for energy to the amount of energy you have available. That's one of the major benefits of optimizing your circadian rhythms. So by kind of coupling this whole thing towards the daytime and aligning energy demand with energy supply, you should be able to live with a healthier gut. So all of these factors: supplemental creatine 3 to 5 grams a day, slowly ramp up your fiber, limit foods you're sensitive to and generally inflammatory things. Decreasing sulfur intake doesn't mean you have to avoid meat. It simply means that there's probably an amount that's good for you. When you start cracking sulfur farts, it may be time to cut back a little bit. And then finally, aligning your circadian rhythms. All these factors should be able to help. In addition, with the circadian rhythms, there is actually a good amount of evidence that circadian disruption may play a role in basically any functional gastrointestinal disorder, but also IBD in particular. So that about does it. If you have any questions, pop them down in the comments section below, and be waiting to hear from you. Take care.